hyperbolas. Where are my hyperbolas? Okay, here. Good. Let's choose any. How to determine the asymptote is always a very easy situation. I'll show you why. Because the asymptotes go through 3 points. You only need 2. You don't even need to memorize the formulas. So you want to choose the center, transverse axis, vertices, foci, and asymptotes. I'm assuming that that's what you want to choose. So let's choose.
Can we do 59?
59 you said? Okay. In 59 we have 4x squared minus y squared minus 24x minus 4y plus 16 equals 0. Okay. So first of all, we have to group the terms with x. And remember, in order to complete the square, we have to factor out the leading coefficient. So it's 4x squared minus 6x plus and then minus. And they have to be the same, they have to equal 0. Can anyone tell us what we have to add and subtract? In other words, what I'm saying is, what should I add to these two terms to get a perfect square?
Y plus y minus 4.
So we're not talking about the y yet. We're talking about x only at this point. So 4x squared and 24. I'm only talking about this and this. Do not look at y. So I factor out 4, x squared minus 6x. What do I need to add and subtract to complete the square? Remember the rule. Take the middle coefficient, divide it by 2, and square that. That's the rule for completing the square. What do I need to add and subtract? Anyone? Please.
9.
Exactly. Very good. Now we focus on y. And we have to factor out -4 this time. -4. And I have, I'm sorry, -1, not -4. Because there is no other number. -1. So I have y plus 4y plus and minus. What do I add and subtract to complete the square now? So this is y squared with negative in front, and this is -4y. We have to factor out -1. I did. Sorry, I dropped my whiteout. So we factor out -1. So I have y squared plus 4y. What do I need to add and subtract to complete the square? Of course, it's y squared. Y squared plus 4y. What do I need to add and subtract?
4.
Exactly, 4. Perfect. So this is accounted for, this is accounted for, the x's are accounted for plus 16 equals 0. Now, we complete the square, and I know you're going to say x minus 3, everything squared. Don't forget, 4 is outside, minus 9. 4 is outside. -1 is outside. So we have the y plus 2 squared minus 4. And then plus 16 and equals 0. Now we distribute. We distribute 4 to the perfect square. 4 to -9. -1 to y plus 2. Squared. -1 to -4. Plus 16 equals 0. This term stays. This term stays. And now careful. This is positive 20, negative 36 plus 20 is negative 16, moved to the other side. Let's stop for a minute and think about the steps and see if you have any questions before we continue. Any questions before?
16
I'm sorry, Charles?
divided by 16.
Yes, perfect. Now we have to divide by 16. So 4 divided by 16 will be 4, because we simplify by 4. Here, minus y plus 2 squared divided by 16, and this is 1. Since negative is in front of y, the transverse axis is where? Horizontal or vertical? Maybe I should move to the next page. Where is the transverse axis if x has positive in front and y has negative? Is it horizontal or is it vertical?
Horizontal.
Excellent. Good. Let's identify the center. First of all, can anyone give us the center?
Very negative 2.
Excellent. So I start with that. So 3, negative 2. 1, 2, 3, 1, 2. Here is the center. Good. So A is 2. B is 4. One, 2. 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. Create the box. I call it a box, but it's a rectangle. Draw the asymptotes. They have to be drawn. They're not part of the graph, but they have to be there. And the asymptotes have to go through these 3 points. This corner, the center, and this corner. That's 1. And we will determine it immediately in a second. Okay, the other one has to be this. And now I'm ready to graph the hyperbola. This is it. So now the question is, you can use the formulas that are given to us, but how do I determine this? Well, I know this corner, and I know the center. The center is 3, negative 2. And I know this point, okay, 1, 2. So 5, comma 2. This is at 3, this is at 5, comma 2. So I have 2 points, and I find the slope. y2 minus y1, 4, over x2 minus x1, 2. So the slope is 2. And I have 1 point, or any. So I have y minus y1 equals the slope times x minus x1, where the slope is 2, and 1 point is 3, negative 2. So y plus 2 equals 2x minus 3. I distribute 2x minus 6 minus 2. So this is one asymptote, which is 2x minus 8. So this line is y equals 2x minus 8. in the same way I determined the other one. I know this point, which is 5 comma -6. I know the center. I find the slope. And I use the point slope form to find the equation of this asymptote. So -2, -6, correct? And 5. So that's from these 2 points, you can determine the equation of the other asymptote. Or you can use the formulas.
Professor,
Yes.
when you're drawing the box to do the asymptotes, is A always related to like the x-axis and B is always related to the y-axis?
So yes, because you can have this option or you can have minus and plus. And they will still be the same for the hyperbola. Is that okay?
Yeah, so like even if it's the y term would be first and like the x is negative.
If you have minus in front of x, it will be the transverse axis will be vertical.
Yeah, I agree with that. And then, because I just want to clarify how you make the box to figure it out.
Oh yeah.
System.
So I found that A is 2.
Yeah.
So 2 units to the left and 2 units to the right of the center. And then I found that B is 4 on the y-axis, 4 up, 4 down from the center.
Okay, so say if these variables were flipped, right? So like it was y first in the equation.
And the same hyperbola?
Yeah, would the box be the same or would it be like rotated?
So if we have minus x minus 3, everything squared divided by 4 and plus y plus 2 squared over 16 equals 1. So the center will not change. The center will still be 3 comma -2. And the x will still be 2. A will still be 2. B will still be 4. 2, 3, 4. 1, 2, 3, 4. The box will be the same. And the graph will be this. Any questions? Any questions? Where is my list? Anything else? Anything else we want to look at?
Can you go over geometric series, please?
Yes. Geometric series, very good. So let's take a look. geometric series. Very good. We did not talk about convergence and divergence. This is in Calc 2. You're going to see it then for the infinite series. Okay, so we for the infinite series for the finite series that we talked about, we did not talk about infinite series. Here we're asked to, for this set of problems, we're asked to use a graphing utility to find the sum. For this one, find each sum. So this is an option. That's the only question that we can see when it comes to, or we're given in this class, when it comes to finding or the geometric series. So would you like to pick anything from here just to find the sum?
Can we do 42?
Let's look at 42. So 42, 3 over 9 plus 3 squared over 9 plus 3 cubed over 9 plus dot, 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 plus 3 to the nth over 9. Okay, perfect. Let's take a look. So we're asked to find the sum. So notice what happens here. The denominator is fixed. So I'm going to factor out the denominator. Then we have 3 plus 3 squared plus 3 cubed plus dot, 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 plus 3 to the nth power. Remember the situation here. So we're given, so the sum of this should be 1 over 9, the sum of, actually I don't need to write it as a sum. We can just directly go to right. So this is a1, 1 minus r to n power over 1 minus r. So this is the sum of a finite. Finite because it stops at n. It does not, we don't write plus dot, 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 right? 3 dots. So it's a sum of a finite series. And it's a geometric series. We have to identify the common ratio. Can anyone tell us what is the common ratio here? In other words, I'm asking, what do we multiply this term by to get this? What do we multiply this term by to get this? And so on and so forth.
30.
Yes. So I already identified that the radius, that the common ratio is 3. So this is clear. Now, there is a little bit of an issue because see what happens. I have 3 to the first power, 3 to the second power. So the first term has power 1 for the common ratio. But the first term should have power 0 for the common ratio. So let me go back for a second. Yes, I put it in my recycling bin. So let me just go back to show you the formula. So the requirement for has to have k minus 1. Not k, but k minus 1. And then we can write 1 minus 3. So this is the first term. Then we write 1 minus 3 to the nth power over 1 minus 3. But I do not have n minus 1 in our case. We have, and then the formula works with a1 being 4 and 3 being the common ratio. But here I have n. So I am going to first, from here, jump here. I'm going to first factor out a 3. So I have 3 over 9 in front, and then I have 1, and then I have plus 3, and then I have plus 3 squared, plus dot, 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 plus 3 to n minus 1. Therefore, the first term has the common ratio to 0 power. So this is the first with power 0. This is the second with power 1. This is the third with power 2. This is the nth, basically with power n minus 1. So now I have 1/3, because 3 over 9 is 1/3. And now I write 1 minus 3 to the nth power over 1 minus 3. Because I can apply the formula as long as I have from the first term with no common ratio, the second term with the first common ratio, the third one with 2 of them, and so on and so forth. This is the formula for all this. That's why I had to factor out 3 first. So I simplified. Then I have, this is the first term, a1, 1 minus 3 to the nth, 1 minus 3 to the nth over 1 minus 3. So 1 over 3 times negative 2 is negative 1/6, and 1 minus 3 to the nth power. I will reverse and factor out negative 1 because I have 2 negatives that I don't really like, so I have 3 to the nth minus 1. And this is the sum of the series. So careful, the requirement is a1 first term times r to k minus first to get the sum. That's the requirement for the formula. So this equals basically the sum from k equals 1 through n from a1 r to k minus 1. The sum from k equals 1 to n, the first term, common ratio to n to k minus 1 equals this formula. The first term, 1 minus r to the nth power over 1 minus r. So I had to rearrange all this by factoring out so I can get up until 3 to n minus 1. Because when k is n, the last term is a1, which in this case is 1, times 3 to n minus 1. Any questions on that?
I have a quick question.
Yes?
How did you get the negative 1/6?
Because 1 minus 3 is negative 2, and 3 times negative 2 is negative 6, but I put the negative in front.
Oh, okay. Thank you.
Is that better?